Hello everyone, hope you had a good weekend. This video is going to be over simplifying radicals, all right? We're also going to introduce imaginary numbers. Now that sounds scary, right? Imaginary numbers, but it's not that bad. So in order to start, okay, with simplifying radicals, we need to talk about the perfect squares, okay? So hopefully you know what the perfect squares are. The perfect squares are any number squared. So we've got like 1 squared is 1, 2 squared is 4, 3 squared is 9. So you can keep going, right? You got 16, 25, 36, 49, 64, 81, 100. So that's the first 10. Then we've got 121, that's 11 squared, 144, 169 is 13 squared, 196, 225 is 15 squared. Let's see how many I can get. 256 is 16 squared. I'm starting to lose it right here. Yes, 16 squared is 256. Then we've got 17 squared, that's 289. 18 squared. You guys can type this in your own calculators too if you want. 324. 19 squared is 361. And then 20 squared is 400. So why did we do that? Okay, so when you're simplifying radicals, all right, the first thing you want to look for is my number a perfect square? If your number is a perfect square, if it's in that list, you could just take the square root of it, right? So for example, the square root of 49 is 7, right? The 7 is a perfect square. 7 times 7 is 49. Same thing for this one, right? 225. 225 is a perfect square. It's right there. And that was 15 squared. So the square root of 225 is 15. Here we have 144. Okay, so with a number out in front, what does that mean? Okay, well, it just means that you have a number, right? It's being multiplied by the square root of 144. And we know the square root of 144, that's 12. So now we have 2 times 12. And so that gives us 24. So if your number is a perfect square, you can kind of do it like this. If it's not a perfect square, all right, for example, 112, that's not a perfect square. We need to break this up, right, into 2 factors that multiply to make 112. And the catch is that it has to be a perfect square, one of your 2 factors, okay? So we need to figure out which of these numbers up here, these perfect squares, divide into 112. So I don't know, right? You guys might not know either. The way to do that is just start dividing 112 by numbers, all right? So I divide 112 by 4, and I get 28. Now, you might be tempted to say, okay, well, that's 4 times 28. But because we're smart math students, we know that 28 is also divisible by 4. So that means 112 is divisible by 4 twice, which means that it is divisible by 16. And sure enough, if I put that in my calculator, 112 is 16 times 7. So we're going to break up square root of 112 into square root of 16 times the square root of 7. Square root of 16 is 4. And so we have 4 radical 7. So the purpose of simplifying is to get the number inside the radical to be as small as possible. So you don't want to just leave it as, 4 times 28, because then you have 28 inside the radical and 7 smaller. Next one, 245. I don't know. I'm pretty sure 245 is divisible by 9. So, I'm going to try it. Again, you just got to kind of try stuff. It's not divisible by 9. All right, so we got to kind of look here. What do we think 225 or 245 is divisible by? Is it divisible by 49? It is divisible by 49. Okay. So 245 is 49 times 5. Square root of 49 is 7, so we have 7 radical 5, I recommend you guys trying some of these on your own before watching me do it. For this one, we've got 72, And I already know off the top of my head that 72 is the square root of 36 times the square root of 2. And so notice how I'm still leaving that 5 out in front when we're breaking this down. So the square root of 36, that's 6. And then 5 times 6 is 30. So whatever number you bring out in front, that'll just multiply by whatever you already have out in front if there's a number out there. Last, what if we're multiplying radicals, so here, these don't equal anything, right? So, you can't break up 6 or 15. So I'm actually going to multiply those together. You're allowed to do that, okay? So 6 times 15, that's radical 90. Okay, well now I can break up 90 into radical 9 times radical 10. The square root of 9 is 3, so now I have 3 radical 10 as my answer. So you're allowed to do operations with things, all right, multiplication and division. So kind of the same thing here, right? We have the square root of 45 over the square root of 5. So if we want, we can actually divide those two numbers together. So 45 divided by 5, that's 9. So this equals just the square root of 9, and we know the square root of 9 is 3, so that equals 3. For the last one, if we have two perfect squares, like we see here, you should be able to recognize 4 and 9 are both perfect squares. We can't actually divide those, but we can take the square root of both numbers. So the square root of 4, that gives us 2. The square root of 9, that gives us 3. So this would equal 2/3. So that's just how to simplify radicals. Now, I said we're going to be talking about imaginary numbers today. So the imaginary numbers, right? So there's something called an imaginary unit, and that's just I, all right? And I is defined as being equal to the square root of -1, okay? So if you haven't heard before, all right, you're not allowed to take the square root of a negative number. If you try and put it in a calculator, you're going to get either error or undefined or something, because no two numbers can multiply to be negative. Okay, so nothing is going to multiply to make -1. So what we say is that I times I equals -1. So I is defined as the square root of -1. So when we're doing problems like this, all right, you're always going to break up your number into its positive piece and then its negative sign. So that negative sign is always going to turn into the square root of -1 times the square root of 9, okay? Just like that. That's what, a negative sign does. It's -1 times a positive number. And so what happens is the square root of 9 is 3, all right? And then the square root of -1 is I. So you always just replace the square root of -1 with I. So the square root of -9 actually equals 3I. And you might say, well, this is stupid, it's imaginary. We call it imaginary, but they have real consequences, right? And they have real uses, and we'll kind of see those later. So we're just kind of doing the same thing we did above. We're kind of breaking them up. So 196, if I remember, that's a perfect square, right? Let's scroll up here. Yes, 196, that's the square root of 14, I'm sure. So this is equal to the square root of -1 times the square root of 196. The square root of 196 is 14. We turn the square root of -1 into I. All right. Here, so can we break up 5? No, right? We cannot break up 5. So what do? We still break it up into the positive piece and the -1, but the square root of 5 just kind of stay the same. So the square root of -1, that becomes I. And then we have the square root of 5. So this is just kind of like I times the square root of 5. So you always want to turn that negative sign into an I and get it out of the square root. A couple more. All right. Square root of -80. Okay. Let's see. So the square root of -80. So that becomes the square root of -1 times the square root of 80. Now we need to break up 80. So again, you might be tempted to do 4 times 20, but hopefully you would know that 20 could then be broken down further. So a better way to break this up is the square root of 16 times the square root of 5, okay? And then you have your square root of negative 1 still out in front. So the square root of 16, that becomes 4. Square root of negative 1 is I. And then we have the radical 5. So we have 4i radical 5. So that's how you would do it, if it wasn't a perfect square. Again, 32, this one is pretty easy. 32, that's 16 times 2. So we've got the square root of negative 1 times the square root of 32. Oops, that was wrong. So 32 breaks up into the square root of 16 times the square root of 2. So the square root of 16 again is 4. So we have 4i radical 2. The last one, 192. Let's see, I don't know what divides into 192. I'm going to try 4 first. That equals 48. Now I know for a fact 48 can be broken down further. Let's do 16. It equals 12. 12 can be broken down further. So we can go higher, 36. No, 64? Yes, 64, okay. So we got the square root of negative 1 times the square root of 192. Again, 192, I just said it can be broken up into 64 times 3. So notice again how I went for the biggest prime number I could. All right, you always want to do that. So the square root of 64, that's 8. Square root of negative 1 is I. And then we have radical 3. So our answer is 8i radical 3. So we're just kind of getting, some practice with this today, introducing I. This stuff's going to be coming up all unit, okay? So go ahead and give the practice a try, all right? And if you have any questions, let me know, and have a great day.